In our quest to find life beyond Earth, we've looked far into the cosmos, searching distant planets and moons. But what if one of our most promising candidates has been right next door all along? While Mars captures headlines today, in the 1960s, scientists were captivated by a different planet, Venus, Earth's mysterious twin sister. Venus and Earth share remarkable similarities. Both planets were born from the same cosmic material about 4.5 billion years ago. Venus is only 20% smaller than Earth, making it our closest match in size among all planets. Both are rocky worlds with substantial atmospheres, and both orbit in what astronomers once considered the habitable zone of our solar system. The early similarities were so striking that early astronomers and science fiction writers often imagined Venus as a tropical paradise, perhaps teeming with exotic life. But reality would prove far more intriguing and terrifying. Imagine being transported to Venus's surface. The experience would redefine your understanding of extreme. The atmosphere is a thick, yellowish blanket of clouds, but these aren't water clouds. They're made of sulfuric acid, as corrosive as the acid in your stomach. It actually rains this acid on Venus, though the droplets evaporate before reaching the surface due to the intense heat. Speaking of heat, the surface temperature reaches a staggering 470 degrees Celsius, 878 degrees Fahrenheit, hot enough to melt lead. This heat is trapped by Venus's thick atmosphere, creating a runaway greenhouse effect that makes Earth's climate concerns look mild in comparison. The pressure at the surface would crush you instantly. At 90 times Earth's atmospheric pressure, it's equivalent to being nearly a kilometer deep in Earth's oceans. Any spacecraft we've sent to the surface has survived for only minutes before being destroyed by this hostile environment. But Venus wasn't always this way. Recent studies suggest that for perhaps 2 billion years, Venus had liquid water oceans similar to Earth's. That's an extraordinarily long time, longer than it took for life to evolve on Earth, from single-celled organisms to complex life forms. Analysis of Venus's surface features suggests these ancient oceans shaped the landscape. We can see evidence of what might have been coastlines, river valleys, and even possible tectonic activity, all essential ingredients for life as we know it. Something catastrophic happened to transform this potentially habitable world into the hellscape we see today. Scientists have several theories. Perhaps Venus lost its magnetic field during a powerful solar storm, leaving its atmosphere vulnerable to the solar wind. Or maybe Jupiter's gravitational influence altered its orbit slightly, pushing it closer to the Sun. Whatever the trigger, the process that followed was devastating. As Venus received more solar radiation, its oceans began to evaporate. Water vapor, a powerful greenhouse gas, trapped more heat, creating a vicious cycle. As temperatures rose, more water evaporated, creating more heating, until eventually the oceans boiled away completely. The water molecules themselves broke apart. Hydrogen escaped into space, while oxygen combined with other elements to form the thick carbon dioxide atmosphere and sulfuric acid clouds we see today. Our knowledge of Venus comes from numerous missions that have braved its hostile environment. Of 46 missions targeting Venus's surface, about 10 to 15 succeeded to varying degrees. The Soviet Venera missions of the 1960s and 1970s provided our first direct views of Venus's surface, an achievement that required incredible engineering. These probes survived the extreme conditions for up to 127 minutes, sending back unprecedented data and images before succumbing to the hostile environment. The photos they returned show a barren, rocky landscape under an orange-tinted sky, a truly alien world. While Venus's surface is clearly uninhabitable today, scientists have discovered something remarkable. 50 to 60 kilometers up in Venus's atmosphere, conditions are surprisingly Earth-like. At this altitude, temperatures range between 30 to 70 degrees Celsius, 86 to 158 degrees Fahrenheit, and the atmospheric pressure is similar to Earth's surface. This discovery led to a fascinating possibility. Could life exist not on Venus's surface, but in its clouds? It might sound far-fetched, but on Earth, we've found microorganisms that can survive in suspended water droplets in our atmosphere. The constant cycle of acid rain evaporating and returning to Venus's upper atmosphere could maintain a permanent aerial ecosystem. The thick cloud layers would even protect these hypothetical organisms from harmful ultraviolet radiation, while the atmosphere contains all the chemical ingredients necessary for certain types of life: carbon dioxide, sulfur compounds, and even small amounts of water vapor. The hunt for life on Venus got a major boost in 2020 with the discovery of phosphine in its atmosphere. This is significant because on rocky planets like Venus, phosphine typically only comes from living organisms. While non-biological processes can produce small amounts of phosphine, the quantities detected on Venus were much higher than expected. Initially met with skepticism, this discovery was later confirmed by more detailed observations. The research team also detected another intriguing compound, ammonia. Like phosphine, ammonia is unstable in Venus's atmosphere and shouldn't persist unless something is continuously producing it. The researchers estimate a 10 to 20% chance these chemical signatures come from living organisms, with an 80 to 90% chance they're from unknown chemical processes. While these odds might seem low in the context of searching for extraterrestrial life, they're remarkably high. Even a 1% chance would justify sending missions to investigate. That's how monumental such a discovery would be. Several new missions are planned to explore Venus's mysteries. NASA's Da Vinci probe will descend through the atmosphere, analyzing its composition in detail. The proposed Morning Star mission could specifically look for signs of life in the cloud layers. These missions could revolutionize our understanding of Venus and potentially collect the first evidence of extraterrestrial life. But they face enormous challenges. The same conditions that make Venus such an intriguing target also make it incredibly difficult to explore. Creating spacecraft that can survive Venus's extreme environment requires innovative engineering solutions. The surface temperature would melt traditional electronics, while the pressure could crush standard equipment. The corrosive atmosphere poses additional challenges for any instruments exposed to it. Yet these challenges are driving technological innovation. New high-temperature electronics, advanced materials, and novel design approaches are being developed specifically for Venus exploration. These innovations could have applications far beyond Venus missions. Understanding Venus is crucial for several reasons. First, it provides a natural laboratory for studying extreme greenhouse effects, offering insights relevant to Earth's climate change. Second, studying Venus helps us understand how habitable planets can become uninhabitable, critical knowledge as we search for life on exoplanets. But perhaps most importantly, if we do find life in Venus's clouds, it would be one of the most significant scientific discoveries in human history. It would prove that life can arise independently in our solar system, suggesting it might be common throughout the universe. The mystery of Venus reminds us that sometimes the most extraordinary discoveries might be hiding in plain sight, not in the distant reaches of space, but right next door, in Earth's hellish twin sister. While its surface may be extremely hostile to life as we know it, the possibility of aerial life in its clouds challenges our assumptions about where and how life can exist. As we continue to explore our solar system and search for life beyond Earth, Venus demands our attention. It's not just a cautionary tale of a paradise lost to runaway greenhouse effects. It might be harboring one of the most important scientific discoveries we could ever make. The only way to solve this mystery is to return to Venus with new tools, new questions, and open minds. While Mars may dominate the headlines, Venus might just hold the key to answering one of humanity's most profound questions. Are we alone in the universe? As we conclude this journey through Venus's mysteries, remember, every time you look up at that bright point of light in our evening or morning sky, you're seeing a world that could completely change our understanding of life in the universe. The next chapter in the search for extraterrestrial life might not be written on Mars, but in the acid clouds of our sister planet. Thank you for joining us on this journey to Earth's mysterious twin. If you're fascinated by the secrets of Venus and the search for extraterrestrial life, don't forget to subscribe to Deep Science and hit that notification bell. See you in our next cosmic adventure.